Hi everyone, welcome to this recording for Unit 45. It deals with the planets Jupiter and Saturn. And in this unit, we are going to talk about basically the atmospheric features of these planets and also their internal structures. We'll also explain the processes that basically generate their main features, especially the red giant spot or the great red spot on Jupiter, and then explain what makes the interior of this gas giants hot because they are too far away from the sun. So we need to understand why they are so hot. And then we also talk about the liquid metallic hydrogen that must exist in their inside of these planets. Okay, so here are the two planets basically side by side, and also next to them is Earth. Jupiter is 5 astronomical units from the Sun, meaning it's 5 times further away from the Sun than the Earth is. Jupiter, on the other hand, is twice as much. It's 9.5 times astronomical units. I mean, Saturn, that is, okay? So Jupiter is 5 astronomical units, Saturn is 9.5 astronomical units. Jupiter is 11 times the diameter of the Earth. So if the Earth is 6,000 some odd kilometers, add that by 11, so it's going to be around 70,000 kilometers in radius, okay? And then Saturn is not that much smaller in terms of physical size. So it's about 9.5 times. So the discrepancy is about two Earths basically. When you put two Earths next to one another, when you have Jupiter and then remove about 1.5 Earths, basically that's the size of Saturn. So it's a big planet, at least in terms of physical size. In terms of mass, though, it's completely different. Jupiter is 300 times the Earth's mass, whereas Saturn is only 100 times. So basically, you're looking at two balls that are of the same size, except almost the same size, except one of them is 300 times more massive, which means it's more denser. So the density is more for the case of Jupiter than that of Saturn. The main features on Jupiter itself, if you look at it, and it's actually visible now. Times we are toward the end of the winter. We are actually the end of February and the beginning of March. So and it's visible in the sky. Actually, all of the planets are nowadays. We are in 2026. So we have this zones in here that are kind of a light color, and we have belts in here that are of dark color. Okay. So you can see these features even with the small enough telescope. I mean, like 5-inch telescope, you can see these features. And then we have this great red spot. Okay, the structure in terms of Jupiter, it's 90% hydrogen. That's liquid. I mean, gas hydrogen, and also 10% helium. Okay, so they are made out of the stuff that other stars are. At least Jupiter is the same things that basically makes up the sun and other stars is what makes up this planet. Okay, there are traces of other basically nitrogen and carbon-based structures, like you have water and here ammonia and methane. It rotates super fast. I mean, by the time the Earth spins once around its own axis, Jupiter would have done 2 times. So imagine something bigger than the Earth by 11 times spinning this fast. If it were to spin just as fast as the Earth, it would be super fast because it's big, okay? But now it's actually spinning actually twice as fast, more than twice as fast, because the Earth takes 24 hours to complete one rotation, whereas Jupiter does it in less than 10 hours, okay? Which makes it, that's why it has kind of a bulging toward its equator, because it spins super fast, that it's actually a little bit flattened in the middle, okay? Its upper atmosphere is around 160 Kelvin, so that you know this is cold, okay? The Earth's temperature here, so that you know the water freezes 273. We are on average about 300 Kelvin. So this is about half the temperature in Kelvin, that is, okay? So I'm not talking about Fahrenheit or degrees Celsius. Saturn uh, Has also bands, but they are not so visible. I mean, with the telescope 5 inch, even a 10 inch, you're not going to see these features. It looks kind of a one block in terms of the structures. Okay, but there are also bands that are also parallel to one another, and they go around the basically around the planet just like Waiter does. Uh, it's mainly gas, hydrogen, 96%, and trace and 4% of helium, and traces of other compounds similar to what Jupiter does. Okay, so it seems like since it formed a little bit further, it had the chance to gather more of hydrogen than Jupiter did. Okay, its outer atmosphere is a little bit actually colder. It's 130 Kelvin. Remember, Jupiter is closer to the sun, so it must be a little bit actually hotter than that of Saturn, which is a little bit further. Remember, Saturn is 9.5 times further from the sun as the Earth is, whereas Jupiter is 5 times only. So Jupiter is midway between the Earth and between the sun and Saturn. Okay, so by the time you reach Jupiter, you still have to travel as much as the same distance you have to go to reach Saturn. So it's not like they are close from one another. They're super far away from each other. Okay, and it's even flatter. And again, because it has lower densities, as I was talking about the mass, that it's only 100 times bigger than the Earth, whereas Jupiter is 300 times. So the gas is easier to deform than because they both go at the same speed almost. As a matter of fact, Saturn goes slightly slower. It takes 10.7 hours to spin once around its axis. And that's also super fast, so that you know, because given their sizes, they're too big and they spin too fast for their size. Okay. In terms of internal structure, again, these are models. They are both in hydrostatic equilibrium in a sense that you have the force of gravity is fighting the internal pressure, and they reach equilibrium. Okay, so without gravity, the gas will be basically uniformly distributed, but because gravity will start to pull on the upper layers, they press more and more on the lower layers, so they are higher in density than the upper layers. And this is true for any structure, even for the Earth, for example. The lower atmosphere is at a higher pressure than that of the upper atmosphere. Same thing. The water all the way to the bottom of the ocean is at a higher pressure than that higher up. Okay, so this is a common feature because this is how gravity works. In terms of its structure, we know its outer structure has this mixture of basically hydrogen and other gases, mainly hydrogen though, for both planets. And then as you go further and further, the density starts to increase more and more to a point that hydrogen becomes liquid. This is a state that is foreign to us. We don't understand. We cannot even replicate it because of the tremendous pressures that you need in order to reach to compress hydrogen. So this is extremely extreme case. The reason why we know we must have hydrogen, because the planet is mainly hydrogen. From the density, it must be hydrogen. I mean, it must be gaseous, and the lightest one is hydrogen, and we know that for a fact. So what explains the magnetic field? Then in this case, it must be a conductor of some sort. And the only one that is available for you is hydrogen. It cannot be helium. Helium is an inert gas, although you have a huge quantity of it on the planet, but it cannot. So the only one that can do it. So again, these are models, okay? The only explanation for it we have is that we must have liquid hydrogen, okay, at extreme high temperatures. And it's conductive in this case because hydrogen sits on the same line as all of the other metals in terms of the periodic table. I mean, it's kind of a weird element. It doesn't behave more like it has its properties all over the map. But for this special case, because of the high temperature and the high pressure, it must act like a conductor. Okay, it must act like any other metal, like iron, for example. Okay, in the case of the Earth, it's the iron core that gives it its magnetic properties. In the case of these two planets, then it must be the liquid hydrogen. Okay, and then again, the models suggest in here, in order to mimic the properties, first of all, they must have some sort of an inner core that is mainly basically like the one for the Earth that is rock and iron and all of that, because that's how all of the planets must have started. Again, this is based on best theory that we have right now for planetary formations, and that is this planetismos as they form start together to to to, to clunk to one another, and as they do, they bring more and more materials, and that's how the planets form. So we must have a rocky inner core that is under tremendous pressure, so it must be super hot too. And because this, they form past the frost line, so they must also have some sort of a liquid water, because liquid water is less dense than this rocks and this iron, so it must be in the outer shell. Again, this is the best models we have for both of them. We really don't have, at least right now, I mean, we have some evidence through the magnetic field and all the things and the internal structure, but this is the best models we have to fit everything together in terms of their structures. Okay. Again, Jupiter's density is 1.3 kilogram per liter. That is the same density of the air, this air that you have in here in the room. Saturn's density is 0.7 kilogram per liter, which means the density of water is 1 kilogram per liter. This is less dense than the water, meaning if you take the entire planet of Saturn, and if you have a bathtub that is big enough to contain it. Remember, Saturn is about 10 times the size of the Earth, so it's a bathtub that is 10 times bigger than the Earth, okay? And you put Saturn, it should not sink because of the fact that its density is less than that of the water. Both of them are in a hydrostatic equilibrium, and mentioned that because that's how gravity works with the pressure coming from inside. We don't have a solid surface, but as you gradually go in and in, the pressure starts to increase to a point that probably you cannot penetrate anymore. So even if you stay intact, okay, because you're going to be also crushed under that same pressure, okay? So there is no solid surface, but it's gradually becomes thick and thick until nothing starts to move, basically, and you reach that state of super high temperature liquid hydrogen that explain its magnetic properties. Okay, but both of them generate a lot of heat internally. Okay, and as I said before, they both of them have their inner cores that is most likely bigger than that of the Earth. Okay, and so where is that heat is coming from? It's probably the relic from when they formed, as the material starts to fall more and more, and potential energy, gravitational potential energy, converted into heat, into kinetic energy, and that heat is retained and it's released on billions of years, and it's still there. So it's a relic here from when they heat from when they formed. So it's still there. Okay. There is not enough radioactivity to explain all of that heat in there, and they must have some radioactive materials too, but it's not enough to explain. So the best explanation for it is from the time when they formed. Okay, and they both generate more heat than they receive from the sun because they are too far away from the sun. In terms of winds, because of the fact they spin super fast and they are mainly gas structures, they can reach the winds can reach speeds of about 500 kilometers per hour. That's faster than any wind that you can have here on Earth. And except Saturn can have winds running faster again because probably of its low density, okay? And now the bands form because of the different the Coriolis force, and the Coriolis force is the one that is responsible, first of all, for the formation of the weather on the Earth. The same thing that hurricanes form on the Earth because of that. So basically, the Earth is spinning, and the weather is moving along that. So there is another force called the Coriolis force that forms. Okay, there is a centripetal force that forms from any object basically spinning, going around on a curve. In addition to that, there is a Coriolis force. Both of them are inertial forces. Okay, it's the same force that causes your bathtub to spin in one direction and not the other in another hemisphere, and vice versa. Okay. The red giant spot is again when these two vortices, basically the two layers of the air, are moving in opposite direction and somehow they get trapped in one region or the other and they form a vortex, like basically the different kind of weather phenomena that form in here on Earth when you have hurricanes. Except because the atmosphere goes so deep, there is no mountains to slow it down. And like the Earth in here, it has a land that slows down the and kill actually all of the weather that forms. Doesn't really stay rotating forever. Here, there is nothing to slow it down. As a matter of fact, the Great Red Spot on Jupiter extends about 50 kilometers in the atmosphere, similar to our weather, and goes as deep as probably 200 kilometers or more, and it's still there is nothing to stop it. So that's why we know it existed since the first time that Galileo looked at it in the 1600s with his own with the telescope that he basically converted from the one that was used for spying, and now he saw it there, and we still see it. At times it shrinks a little bit and grows, but it's the same place, it's the same spot. Okay, so that's basically the theory that we have. That's not the only one, though. We have a lot of them that form on Jupiter and Saturn, and they dissipate on on a shorter scale because probably they have things to slow them down or they collide with other weather basically formations in the atmosphere. But for this one, it's sustained for a long, long time and it goes for a long time. And in this picture here, we saw also the poles of Jupiter again. They have all kinds of collisions between the different layers, and that's why the region appears chaotic a little bit. Okay. Uh, Also, the same things are happening also on Saturn, as I mentioned before. And there are thunderstorms and lightning and all kinds of weather phenomena because you have friction involved, so there is statics everywhere and uh, interactions along these lines in both of them. Okay, the magnetic field is so strong, and as I said, probably most likely it has to do with the metallic liquid hydrogen. It's the structure of both planets, and it's super strong. It's actually 20,000 times stronger than the magnetic field of the Earth. And for the case of Saturn, it's only 500 times bigger, but it's still, both of them are super strong magnetic field and they extend for a very, very big region, especially for the case of Jupiter. Okay, and it impacts all the way to the moon Io. So they extend for a long period of place, which presents actually a challenge in terms of our missions to both of these planets, especially in terms of Jupiter because of its strong magnetic field. Okay, thank you.